Welcome to Your Math Explained, where we make math simple and clear. My name is Julian, and today we'll look at two simple problems that revolve around geometry. The first problem is for grade 9 and 10 students, and the second problem is for grade 11 and 12 students. In both problems, we turn the provided visual into an equation so that we can find the missing quantity. Pause the video now if you haven't had a chance to read it, otherwise, let's jump in. In this grade 9-10 problem, we're given a few quantities that we can include in our diagram. So right away, we see that PT is equal to 4 and RV is equal to 8. Our goal is to figure out the area of the entire rectangle. And so when I look at the problem, it looks like I've got something that I haven't used yet. This 92 needs to be included. So we're being told that when PQRS, so when that shaded square is removed from the overall rectangle, the area, the remaining area, so the white part, is equal to 92 meters squared. So for us to create the appropriate equation to model that area, we're probably going to need to figure out what RS and SP are. And given that we're being told that it's a square, we can create a variable x to represent the two sides of that shaded region. Now the equation. So we would have the area of the rectangle minus the area of the square equals to 92. That is the format of the equation, and we can substitute some expressions in. The area of the rectangle, so that would be the length here, times the width here. We have those quantities. That would be 8 plus x, and then times 4 plus x. And then we have the area of the square. So looking at the area of the square based on what we've just called them, that would be x and x. So that would be x times x, and that is equal to 92. So this becomes a nice quadratic equation for us to work with. When we expand this using the distributive property, we'll get 32 plus 12x plus x squared minus x squared equals 92. And conveniently, the x squared terms will cancel out, so we have 12x equals 92 minus 32 will be 60. And so x is equal to 5. Now that we know the value of x, we can calculate the area of the entire rectangle. So therefore, the entire rectangle would be 8 plus 5, because that is the length of the top. And then we've got the width now becomes 4 plus 5. So this is 13 times 9. So our overall area is 117 meters squared. In the second problem, for the grade 11 and 12 students, we have a cube that's n by n by n, and we'd like to cut this into smaller cubes with side length 1. We're being told that there are 125 of these smaller cubes that don't have any painted purple faces. And we're also told that only 3 of the faces are being painted purple. So the two back sides and the bottom don't have any color to them, or at least they're not purple. Our goal is to find how many of those little cubes will have no painted purple face. So when we look at this diagram, I think the immediate thing for me is that we can cut out. Imagine if we're just skimming that first layer off on this side here, because that's purple, right? We don't really want to see it. So we can just imagine ignoring that section of the shape. What that would create is a bunch of cubes over here that have a length of n minus 1. Now we're actually going to repeat that process because we can skim another layer on the top So imagine if we were doing just eliminating the top here, that top row, we would also be shrinking the height by 1. And then finally, we can do one more skim of the final side, the width, and we would also be creating an n-1. So I'm not going to draw that last line because I think the idea is the same. So realistically, if we've shaved off 3 of those faces, we have a cube that is of dimensions n-1 times n-1 times n-1. And this is going to represent all the cubes with no purple faces on them, so that would be equal to 125. Now, n-1 times n-1 times n-1, we could certainly expand that, but that's also the same as n-1 cubed. So we can cube root both sides, and we'll get n-1 equals 5. And then solving for n, we've got n equals to 6. And that wraps up this week's problems. Check out the problems I've posted for next week's video. Try them on your own first, and see how you'd approach them. And as always, if you found this helpful, don't forget to give the video a like and subscribe so you don't miss the next one.
That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.